Section 1. Power, energy and efficiency calculations. So the three equations are power equals energy divided by time, efficiency equals useful energy divided by the energy input, and rearranging the first equation you can have energy equals power times time. So E is energy measured in joules, P is power measured in watts, T is time measured in seconds, and then useful energy output is in joules and energy input is also in joules. Question 1. So put a box around the quantity that is asked for, underline the given values, and then you put your numbers into the equation. So these are low demand questions where they give you the equation. So you simply put 30 and the answer is 60 joules. Question 2. It's asking you for the efficiency. Put a box around the efficiency, underline the given values, put your numbers into the equation. So if it's a bike, the useful output of a bike is 3000 joules of kinetic energy. So you do 3000 divided by 5000, which is 0.6, or you could write that as 60% efficient, and there's no units for efficiency. Calculate the energy transferred by a light bulb in 20 seconds if it has a power of 11 watts. So you write down the equation, underline the given values, put a box around what you're asked for, and the power is 11, time is 20, and so your answer is 220 joules. Okay, standard demand, where you are asked to know the question. So write down the equation that links power, energy and time. So E equals P times T. This time they're asking you for the power, underline the given values. So your energy is 500 equals power that you don't know multiplied by the time, 25 seconds. So your power is 500 divided by 25, and that gives you an answer of 20 watts. Okay, next question, efficiency. So you write down the equation, efficiency equals useful energy output total input. And the question is asking you for the useful energy output. It gives you the efficiency and it gives you the energy supplied, or the energy input. So you write down the equation, efficiency equals useful divided input. Now it gives you the efficiency as 15%, but you convert this to a decimal. So that is 0.15 equals the useful energy that you're trying to find divided by the energy input, which is 1400. So to find the use, you have to multiply both sides by 1400. So your answer is 0.151400, and that gives you an answer of 200. Okay, so the next question, we're wanting down the equation. So energy equals time transferred. They give you the power is 2 kilowatts, time in 15 minutes. So you've straight away remember that 2 kilowatts is 2000 watts, so you multiply by 1000, and 15 minutes is 15 times 60 seconds. So you write out the equation and then you put, so you write power is 1000 watts, time is D, and that comes to 1,800,000 joules. And that, to convert it to megajoules, that would be 1.8 megajoules. Question 7. So you write down the equation for efficiency. So it's the useful energy output divided by the total input. So this time they're asking you for the energy supplied, so plug your equations, put a box around the quantity asked for, underline the given values. So your efficiency is useful output divided by the total input. Your efficiency is 5%. But you don't write that as a percent, you convert it to a decimal. So you write 0.25 equals, the useful energy output is 8750 divided by the total input, which is the same as the energy supplied. And so to work out the total input, you've got to rearrange this equation. So to do it in 2 steps, you can multiply both sides by the total input. So you would write 0.25 times the total input equals 8750, and then you can see to work out the total input, or the energy supplied, you would do 8750 divided by 0.25, and that gives you an answer of 35,000 joules. Okay, so the standard stroke higher questions are a little bit harder again. Question 8.1, so this is a higher standard question where you have to change the subject and something else to look for. So book your equations, put a box around what the quantity is asking for, underline the given values, so you notice straight away that's 5 kilojoules hopefully, and the time is 10 minutes. And you've got to give your answer to 2 significant figures. So you write out the equation, so you've got to know that one off by heart. You're given the energy, 5 kilojoules, so you convert that into joules, equals the power that you're trying to find times the time. 10 minutes is 10 times 60. So to work out the power, you're going to do 5,000 divided by 10 times 60, which is 600, and that gives you an answer of 8.3 watts to 2 significant figures. 9.1. So this time you're trying to find the useful energy output of a fan. It gives you the efficiency of 35%, and it gives you the energy supplied 5.4 kilojoules. And again, you've got to watch out for your significant figures. So you write out the equation. Efficiency equals useful output divided by the energy supplied, or the energy input. So we give you the efficiency of 0.35. You've got to find the useful output divided by the energy supplied, which is 5.4 kilojoules, so you've got to convert that into joules, so that is 5400. To convert kilojoules to joules, you multiply by 1000. So your useful output is 0.35 times 5400, and that gives you an answer of 1900 to 2 significant figures, and the unit is joules. Okay, question 10. How long is a heater on for if it transfers 2,700 kilojoules of energy and has a power of 5.5 kilowatts. So it's asking you how long, so it's asking you for the time. Underline the given values and note that you've got joules in kilojoules and you've got power in kilowatts, and you want your answer to 3 significant figures. So you write out the equation, energy equals power times time, you put your numbers in, you're given 2,700 kilojoules, so that is 2,700,000 joules. You're given a power of 5.5 kilowatts, so that's 5500 watts, multiplied by the time. To work out the time, you're going to do the energy, make sure you get your zeros right, divided by 5,500, and that gives you a time of 491, and the unit is seconds. Question 11. Calculate the energy supplied. So this time put a box around the energy supplied. It's giving you the efficiency and it's giving you the energy supplied, 7 kilojoules. So again, you write out efficiency equals useful output divided by energy supplied. So they give you efficiency. Remember to convert that into a decimal. So you write 0.34 equals the useful output, which is the 7,000 joules, which is transferred to your electrical circuit, divided by the energy supplied. So to rearrange this, you multiply both sides by the energy supplied. So 0.34 times the energy supplied equals 7,000. So to find the energy supplied, you're going to do 7,000 divided by 0.34, and that comes to 20588, and the unit is joules. High demand questions. So there's more to think about and more to look out for. But you do it in the same way. You underline the given value. So they're giving you the time, they're giving you the efficiency, they're giving you the useful kinetic energy, 3.7 kilojoules, and they're asking you for the power input of the fan. And they need your answer to 2 significant figures. So the first thing you want to do here is to work out the energy supplied, and then you're going to work out the power. So the first equation that you're going to use is efficiency equals useful energy divided by the energy supplied. So the efficiency is 40%, so you write 0.40 equals the energy supplied, the useful energy is 3.7 kilojoules, so that is 3700, divided by the energy supplied. So you rearrange this in the same way as you did in the last question. So the energy supplied, so missing out a step, the energy supplied is 3700 divided by 0.4. And that comes to 9250 joules. So that is the energy supplied to the fan. The question is asking you for the power. So now you're going to use energy equals power times time. So you know that your energy input is 9250. You don't know the power, but you do know the time, which is 3 hours. And 3 hours is 3 times 60 times 60, because your time has got to be in seconds. And so if you do power equals 9250 divided by 3 times 60 times 60, the answer is 0.86, and the unit is watts. Okay, so let's look at the next question. diesel engine, 35 kilojoules of chemical energy supplied to it. So underline the given values. And this time it's giving you the amount of wasted energy. So you've got to do something slightly different here. You're going to use the law of conservation of energy, in that the total energy supplied is equal to the useful energy plus the wasted energy. So the energy supplied is 35,000 joules, because that's 35 kilojoules. You don't know the useful energy, but you're given the wasted energy. So the useful energy is 35,000 minus 21,000, which is 14,000 joules. You can then use that in the efficiency equation. So your efficiency is useful energy divided by the energy supplied, and so that is 14,000 joules divided by the energy supplied, which I gave you right back at the start of the question, 35,000 joules, and so that gives you an answer of 0.4 or 40% efficient. And remember, there's no unit for efficiency.